Hi everyone. Through this class, we are going to study about hydrogen energy. Hydrogen is the lightest element in the universe. Hydrogen gas is colorless, tasteless, and invisible. It can be transformed into a renewable, non-polluting, and zero-emission energy resource. Since it is the lightest element, it rises in the atmosphere, therefore rarely found in its pure form H2. Although hydrogen is not available in its pure form, it is abundant in nature in other chemical forms such as water, fossil fuels, minerals, biological materials such as cellulose, starch, etc. As a fuel, when hydrogen is combined with oxygen, results in the liberation of energy with water as the only byproduct. Chemical equation is like this: 2H2 plus O2 gives 2H2O plus energy. There are different processes for the production of hydrogen. They are thermochemical, electrolytic, thermolytic, photolytic, biological, etc. First, we discuss thermochemical processes. Thermochemical processes use heat and chemical reactions to release hydrogen from organic materials such as fossil fuels and biomass. Partial oxidation, steam reforming, and thermal decomposition are some of the chemical methods for large-scale hydrogen production from hydrocarbons and alcohols. Production of hydrogen by electrolysis is an old method that found industrial application in the food industry and other activities that need only a moderate amount of gas. Electrolysis involves passing an electric current through water to split water into hydrogen and oxygen. Since water is a poor conductor of electricity, it is mixed with 25 to 30% of alkaline electrolyte such as potassium hydroxide. Hydrogen is then collected at the negatively charged cathode and oxygen at the positively charged anode. Hydrogen produced by electrolysis is extremely pure, but unfortunately, electrolysis is a very expensive process. Schematic diagram of an electrolysis unit for the production of hydrogen is shown in the figure. Thermolytic reaction is the dissociation of water vapor into hydrogen and oxygen at a high temperature. Here, the hydrogen can be separated out by using an appropriate device such as palladium filter. However, practical implementation of this method is extremely difficult. And photolysis is dissociation of water by absorbing photons having an energy more than 5.15 electron volt or 240 nanometer. In the presence of a catalyst, the required photon energy can be reduced. Direct photolysis of water using sunlight is challenging because the required wavelength is very less in solar spectrum reaching the surface of the earth due to the atmospheric absorption. In photobiologic hydrogen production, certain algae can generate the oxygen needed for their respiration by extracting it from water and releasing hydrogen. Hydrogen can be stored as a compressed gas, as a liquid below minus 253 degrees centigrade, and absorption of gas on some appropriate substance such as activated carbon, as a chemical combination of hydrogen to create a hydrogen-rich compound, as metal hydrides that are metal hydrogen compounds, can release and absorb hydrogen reversibly by a simple change of temperature. And for very large scale storage, it may be possible to keep hydrogen in underground formations such as porous rocks, old mines, caves, aquifers, and exhausted natural gas deposits. Next, we consider the uses of hydrogen gas. We can use hydrogen gas as the clean fuel. In the chemical industry, it is used to make ammonia for agricultural fertilizer and cyclohexane and methanol, which are the intermediates in the production of plastics and pharmaceuticals. It is also used to remove sulfur from fuels during the oil refining process. Large quantities of hydrogen are used to hydrogenate oils to form fats, for example, to make margarine. In the glass industry, hydrogen is used as a protective atmosphere for making flat glass sheets. In the electronics industry, it is used as a flushing gas during the manufacture of silicon chips. 5 basic issues regarding the use of hydrogen as energy sources are: it is very expensive, and the storage and the transportation is very difficult because it can leak easily through cracks, holes, pores, etc. The utilization technique is very complex, and hydrogen is highly flammable, and major danger with hydrogen fire and explosion caused by leaks from its storage place. And its cost is also high.